webinar titled Intellectual View of Machine Learning, Deep Learning and its Applications. Now I would like to invite Dr. Muthupandi sir, Director in charge of Madurai Kamaraj University, Madurai, to give the welcome address.
Yeah, very good afternoon, ma'am. And I feel proud and happy to be a part of this international webinar. And I'm here to welcome the gathering as well as the guest of the today's webinar. And first, I would like to welcome our Vice Chancellor, Dr. J. Kumar, who is a man of technology and who is the key for all our activities and achievements. And I really proud to welcome our registrar, Professor Dr. M. Ramakrishnan and also he is the man of technology. He is from the computer science department, a professor in computer science department. And really, I feel proud to welcome you, sir, for this international webinar on intellectual view of machine learning, deep learning, and its applications. And really, I feel proud and happy to welcome our director of Russian Language Institute, which is located at Chennai, Tamil Nadu, Ms. Valentina. Ma'am, really on behalf of the Directorate of Distance Education and on behalf of the organizers and on behalf of Madurai Kamaraj University, we feel proud to welcome you, ma'am, and we are happy to welcome you, ma'am. So, and I welcome the dignitaries. For example, a felicitation address is going to be given by Dr. S. Salima Rabia, and who is working designated as additional controller of examination in the Directorate of Distance Education, Madurai Kamaraj University, and special welcome to the resource person or to the guest of today's speech, the special address, Dr. A. Badmapriya, who is professor and head in charge of Department of Computer Science in the Department of in the Alagappa University, Karaikudi, Tamil Nadu. Really, we welcome you, ma'am, for this intellectual webinar. We can call it as an intellectual webinar. So, and I thank for your acceptance for a special address, and we feel proud to welcome you, ma'am. And the resource person of today's session, Kanev Anton, who is a lecturer in Bauman Moscow State Technical University, which is located at Moscow in Russian Federation. And we really appreciate and we really thank your presence in the intellectual view of machine learning, deep learning, and its application in this webinar. And on behalf of myself and on behalf of the team, wholeheartedly, we welcome you for this intellectual webinar. And I welcome Dr. S. Rajkumar, who is the Associate Professor and Head in the Department of Analytics of School of Computer Science and Engineering in VIT Vellore, located at Vellore at Tamil Nadu. Sir, really your presence makes us a great sense of honor. So thank you so much for your presence. And on behalf of Directorate of Distance Education and Madurai Kamaraj University, I feel proud to welcome you, sir. And I welcome the bread and butter of this webinar, the international webinar, the participants. Without you, nothing is happening. So as a hosting institution, Directorate of Distance Education, Madurai Kamaraj University, I welcome all the participants of this international webinar. So once for all, I welcome all of you and thank you, ma'am. So thank you so much. Ma'am.
Thank you, sir. Now I would like to invite Ms. Valentina, Director, Head of Russian Language Institute, Russian House, Chennai, to give the inaugural address.
Good afternoon, dear friends. It's my pleasure to participate in the inauguration of webinar, and I would like to tell you about Russian Center of Science and Culture in Chennai. Russian Center of Science and Culture was established in 1972 and actively promotes Indo-Russian cooperation, cultural events, Russian language, and Russian education. Russia is home to one of the world's most impressive higher education systems. Talking about Russian universities, I would like to mention Bauman Moscow State Technical University, which is considered one of the best universities in Russia. As a representative of Russian Center of Science and Culture, I am glad to greet Mr. Kanev Anton, lecturer from Bauman Moscow State University, at this event today, and wish that cooperation between Madurai Kamaraj University and Bauman Moscow State Technical University will be continued. Здравствуйте. I say in Russian, hello. So higher education in Russia is recognized around the world, and Russian government scholarship gives the opportunity to Indian students to get free higher education in Russia. It opens the door to lifetime experience in knowing a new culture, language, people, and environment. And I would like to share with you very important information as many students joined for this program. So that registration for Indian students for studying in Russia under the 100% scholarship under Russian government scholarship program 2024-2025 has started. So for getting more information about scholarship, please contact Russian Center of Science and Culture. And don't miss an opportunity to get a world standard higher education in Russia. And if you want to learn Russian language, also welcome to Russian Center of Science and Culture for our online and offline classes. So we'll teach you Russian to speak, how to write, to understand. And so you can, next maybe lecture, you can listen in Russian. You will get an opportunity to learn Russian language from native speakers and through it to be introduced to Russian culture, history, art, and traditions. Thank you for your attention.
Thank you, ma'am. Thank you for your information. Now I request Dr. S. Salima Rabiat, Additional Controller of Examination, Directorate of Distance Education of Madurai Kamaraj University, to give the felicitation address. Madam.
Good afternoon to all. Sorry for the inconvenience. Actually, I am at outside of the university, so please adjust with me. Thank you so much for this kind opportunity. Really, it's the needed time because nowadays each and everything is getting updated. Especially in computer field, we should get updated. Then only we can reach and we can even live the life. It's like going because all the places AI and machine learning is going on in a very excellent way. So this is a very needed one, ma'am. My hearty congratulations to all the participants and Indrani ma'am and their group. Please do it well, and we are always with you to support you, ma'am. Thank you so much.
Thank you, Dr. Salima ma'am. Actually, she is an Andaman. In that situation also, she's tried her best. Thank you, ma'am. Next, I would like to invite my friend and as well as Professor and Head in Charge, Dr. A. Padmapriya, Department of Computer Science of Alagappa University, Karaikudi, to give the special address. Madam.
Thank you, ma'am. Thank you for your nice welcome and making this event happen through online mode. So first of all, I'd like to congratulate the steps taken by the Madurai Kamaraj University for conducting this online webinar for the students about the most wanted, most hot topic, machine learning as well as deep learning. So the patrons, Vice Chancellor of Madurai Kamaraj University, as well as the co-patron, Professor Ramakrishnan sir, Registrar of Madurai Kamaraj University, who have given the permission to conduct this type of event for the benefit of the students. So first of all, I'd like to thank them. And so this event, it is organized by the Directorate of Distance Education, and it was well organized, and it has been happening in a very short span of time, that too in a very nicely presented manner. So congratulations to Indrani madam as well as her team. And as far as the today's topic is concerned, so here the topic given for this webinar is intellectual view of machine learning and deep learning and its application. So actually, these two words, machine learning as well as the deep learning, these two words are the buzzwords. So which is being used in each and every place of our life. We are experiencing artificial intelligence as well as machine learning in each and every application of your life. And nowadays, we are contacting the banks and we are contacting the customer care services. So everything is now powered with or enhanced with the artificial intelligence. So we are chatting with the chatbots, we are interacting with the infobots. So each and every pattern, the way in which we are purchasing in Amazons or whatever it may be, any kind of online platform or any kind of online services that is making use of by us. So it is being well studied by the machine learning. So actually, machine learning is nothing but the ability of the machine to learn by itself. So just like a human, it will start learning by its by means of the guidance from the experts, as well as it can also get the information, learn the information by itself as also. So there are three different kinds of learning. Machine learnings are there. One is supervised, unsupervised, as well as reinforcement learning. So each and every type of learning, it will be having different kinds of applications. That is why if the learning is not in a proper phase, we could not able to do the things in a proper manner. That is why machine learning is playing a major role in nowadays, and it is being used in all the parts of applications. So as well said by the senior professors, so if you are not updated in the field of computer science, and you'll be outdated. So for that reason, this kind of international webinar is being organized to explore the topic of the machine learning to the students. So the syllabus can able to teach us according to the units or content available in the syllabi. But apart from the syllabi, we can explore it by this kind of webinars and all. And I'd like to congratulate the team for organizing such a nice event. And this event is, I wish them all a grand success of this event. And I saw the resource person details. So we are having two well-known resource persons. So they'll provide you an wonderful view about the machine learning as well as deep learning to the students. So I'm also very eager to listen them up. So I wish you all success, and I assure you that the participants of the event will get highly benefited by this kind of resource persons. So thank you. Thank you for giving me the opportunity to meet you all. Thank you, madam.
Thank you, ma'am. Thank you very much. Actually, it is a privilege for me to have you all join us, and the distinct honor to extend a heartfelt welcome to our esteemed chief guest, Ms. Valentina from Russian Federation. In 2023, researchers from Indian Institute of Science and Skolkovo Institute of Science and Technology jointly developed a new artificial intelligence algorithm for machine translation that's more accurate and efficient than the existing algorithm. In 2022, researchers from Indian Institute of Technology, Bombay, and Moscow Institute of Physics and Technology collaborated to develop a new artificial intelligence algorithm for medical image analysis that can help doctors to detect the diseases more accurately and efficiently. So here, artificial intelligence plays an important role in our daily lives. I think for the extension of 25 years, it will be moving with it. And once again, I extend my heartfelt gratitude to our chief guest from Russian House, and the distinguished panelist, the resource person, Kanev Anton, lecturer, Bauman Moscow State Technical University, Moscow from Russian Federation. We are expecting a lot of experience from his valuable information. And Dr. S. Rajkumar, Associate Professor and Head, Department of Analytics, School of Computer Science and Engineering from Vellore Institute of Technology. And he has given more number of webinar and seminars to our Madurai Kamaraj University, and highly knowledgeable and valuable person. To these both resource person is going to share their views and ideas. Really, we are all waiting for that. And I would like to finally, I would like to thank Mr. Basha from the Russian House, who was the intermediate between the Madurai Kamaraj University and the Russian Federation. Really, thank you very much, sir. Now the session may be hand over to Kanav Anton. That lecturer Kanav Anton can start the session. Thank you. Good afternoon, sir.
Yes, hello. Hello, good
Yeah.
afternoon.
Good afternoon. Sir, now the question is handed to you. Hi.
Thank you very much. I can start now, or I should wait?
Yeah, sure, you can start. We are waiting.
Okay. So today I would like to present my report on the topic of data science and machine learning. My name is Anton Kanf, and now I would like to demonstrate my screen. Are you see my screen? Yes?
Yes, yes, sir. It's available.
The sound is good? Yes?
Yeah, yeah, it's clear.
Thank you. So my name is Anton Kanev, and I'm a lecturer at Bauman Moscow State Technical University. Today I would like to present this topic, data science and machine learning. And mostly we will talk about this topic on example of neural network and supervised learning, because it will be clearer for us to understand everything we will talk about. Firstly, about materials at this presentation. I have completed NVIDIA DLI course at deep learning, and I have used these materials. So this certificate means that if you want to use these materials from this presentation, you should insert notion about NVIDIA DLI. But if you just looking, that is not, you don't necessarily to do anything. I'm lecturer in Bauman Moscow State University in disciplines of deep learning and also web application development. And that's why I try to create such materials where you can firstly train your model, and then you can use this model in another web application. So today I will show you how to train very basic, very simple model and save it into the file, and then you can we will look how can we use it in a simple web application. So firstly, let's talk about what is data science and machine learning. Data science is science about data. We use several statistical and other methods to understand dependencies and correlations in our data. The most simple example, we would like to understand, is there some relation between image and class of the object on this image? Can we use image to understand what object can we see? Now it is maybe clear that image of cat, we can understand it, but using different models, using different methods, it will be very challenging to understand. This is very simple example. We have different areas of application, for example, time series prediction, for example, text generation, and so on. But today I will talk about images because it is very simple to understand and to show everything that we would like to understand. The second part of our topic is machine learning. So machine learning is a set of algorithms when we train our computer without detailed programming. So algorithm of our computer like changing during the time. And if our computer will look at one data, it will make one decision. If it will have another data, it will make another decision. And what we need to do this, we need a set of examples to train our model and to solve the problem. This algorithm, it is difficult to code, so we try to get some information from our data. Let's look at examples. If we have image, we can make prediction what class it is. Another more complex task is object detection. When we have image, but we should show one box, one area where this object is placed. And also we can use different colors of boxes to understand which class it is, duck, cat, or dog. And this is mostly classification. So we have two main tasks in machine learning. The first class is class of tasks, or different types of tasks. First is classification, and the second is regression. So classification is very simple. We have some data, and we should understand at which class it corresponds. If we have this task, object detection, it combines two tasks. We should understand which class we see at this box, and then we should understand where is this box. We should understand where coordinates, where is X, where is Y for this box, and how big is it. So this is another task. This is task of regression. We should understand some point, some value for each input. And here is examples of these tasks. If we have regression, it is very simple. We have some data, and we should make some function, for example, that will be the most closest to this data. We will talk later how can we do it. For example, if we have a dependency of weight and height of some human, we can understand then if man or human are taller, it is high, its weight will be bigger. So we have some linear dependency, linear regression between weight and height of the human. And this dependency will be can be very different. Another task is classification. We have some data and we should separate it into some classes. For example, here we can see one blue ones and green ones inputs. It can be, for example, dogs and cats or something else. It can be cities and villages. And it can be shown that these tasks are very similar one to each other because we have some data, and in classification we should understand only separate classes, and in task of regression we should understand some continual value. So in classification we have several values of classes. In regression we have continuum set of values, a very big set continuum. So let's talk about different types of machine learning. We have many types of machine learning, and today we will talk mostly about supervised learning, supervised training, but I will show you also now examples of reinforcement learning and unsupervised learning. Supervised learning is very simple. You have some data. This is input for your method, for example, image. And your method should answer where is this object and make this box and write which class is it. But we should tell our method how this object looks like, that it can learn and then repeat. So at the beginning of training, we should make some data set where we should label every image and label each object on this image to give our method information how our objects looks like and what is our object, what is car, what is bicycle, what is flower, what is building. If we will not show it buildings, it will not know about these objects. It is simple enough and it is good, but it needs a lot of data, and we need to label each data manually. It is very difficult and demand many time. For example, in classification, when we have image of dog, image of cat, or image of one human, image of another human, it can be not such a difficult task. We can simply put one images into one folder and other images into another folder. So it is a very not such a difficult task, not such complex task to make label dataset. But if we have such object detection tasks, for example, we need to understand where is human or where is a feature of some disease on X-ray photo or another information, another image. We need to make all of these boxes. It depends a lot of time, and I take part in some of such projects. For example, in medicine, to label images of glass to understand features of disease, and it remains a lot of efforts, a lot of time to make it. That's why also two types of machine learning are very popular. Unsupervised learning, when we don't have labeled data, we have only image, and we should make something with that. For example, when your phone make folders with photos of your friends, of your family. It is example of unsupervised learning. Nobody show model your friends, your family, but before you begin to use your phone, somebody make a very good model that can understand which folder should contain which photos. This is example of unsupervised learning. Nobody, not you, not other people make this label. Who is this man on this picture? So your phone can make these folders, but it cannot describe it. Who is this person? Is it your family? Is it your friend? We should tell. So if we will tell, it will be more similar to supervised learning. And reinforcement learning, very interesting. We don't have label data, but we have some environment. For example, we have some market, some stock where we make bots or sales. And if we will make good actions that will give us some money, the environment will give us this money. If we will get bad actions and lose our money, so we lose our money, and we can use this measure amount of our monies to understand is it good example or is it bad example, and which side we should train our method. So let's look at these examples. This is example of supervised learning that we use at our course for school students. Our students at the end of the teaching at school can go to us at the vacation and make this project. You can use this QR code to get information about it. This example is in Russian, but you can translate it, for example, using Google Chrome browser. The next example will be in English, so you can simply use it. This is link to our project. This is QR code to our project, to our materials. So what we have here, we have a very simple browser game at JavaScript language. And also our students come here, they make this game using our materials. Then they are playing at ping pong and they save their actions at some file like Excel, like table. Then using this data, this is labeled data. So this is data of actions of our gamer. What is label data? We have place of the ball and we have place of the this pad, and we should understand what should we do. Should we put our pad down or put it up? And this is labeled data. We have information what we have, and we have information what we should do. This is information for our model. So using this table, where is ball, where is pad, we can train our model. And you have also here example of training your model in Google Colab. I will show you today how you can use Google Colab to train neural network model. Then you will get a neural network and use it at this application. So now you see how two neural networks are playing ping pong game in a simple browser, Google Chrome browser. So this is very interesting for students from schools to understand how you can use web application, how can you use neural network, and how can you combine it together. This is example of supervised learning. Very interesting and a simple, unusual, a little unusual. Let's look another example. You can, I think, write your questions in the chat if I have we'll have enough time, I'll try to answer these questions. So here is example of LiDAR. What is LiDAR? LiDAR is a laser detection method. It is like a radar, but radar using radio waves, and LiDAR using light. For example, in our phones, at other house cleaners, small robots, they use LiDAR to understand where are they. But we use LiDAR to make model of some objects, for example, tree. And this is not a 3D model. This is a set of many points. So we have a lot of points. This is not 3D model like in computer games. It is another type of data. But we get this information from LiDAR. How can we use it? In our university, we get from the LiDAR information, this data. We get height, length of the tree, diameter, crown area, and others. Here you can see what is height, what is length, and what is height to crown base, and so on. Here you can see that this is points. This is not 3D model, but you can also make 3D model and use different methods to do it. But if we talk about getting such taxation information about tree, for example, its height, its length, or about building or about car, you need some method, and we use method that are unsupervised. This method called optics and DBScan. You can find our articles in Scopus database about this investigation. So we need to get a lot of points. These points don't have color. So if you look at radar screen, it is only one color. But then we should separate all points into this main part, into the branches, into the leaves. And how can we do it? We can understand where is each point, how close it to another point. And this is good information for us to make this segmentation task. So segmentation task is unsupervised learning. We don't give information what is leaf, what is branch. We only use some method, and it understands if we have many points in one area, this is one part. If we have another dependency, it is branch. If we have small one, it is leaf. Using such unsupervised learning, we can make this segmentation task. And what is reinforcement learning? Reinforcement learning is a good example of also for game or for stock market. This is, I think, the most popular examples for reinforcement learning. So we have some environment, stock market where we can get money, or game where we can win or lose. And we have some agent, for example, our Pacman or some stock dealer that can make actions in environment. And we should understand which action should we do to get win or to get some money from environment. If we will get good money, state, we should repeat such actions. These actions are good. If we lose, these actions are bad, and we don't need to make such actions. So this is a reinforcement learning. But today I will talk about supervised learning. because I have a lot of practice at this, and my course mostly about supervised learning. Supervised learning is classification of images, is object detection of images, is text prediction, and many other tasks. And we use neural networks in supervised learning. Not only neural networks, but all neural networks are mostly supervised learning. This is example of our today practice. Today I will talk about theory for you to understand what is neural network, how it works, and how can we train it. But this is example of our project. What should we do? Here is QR code to our notebook where can we train our model, and this is example how does it work. We have file of the neural network, we have file of the image, and then we can understand using our neural network which class is it. And here you can see if we will move our image for our neural network, it will change its answer. And here we see a lot of useful information about neural network, how does it work. It gives us several answers. Each answer is one value, for example, from 0 to 1. And if we have 3 classes, we have 3 outputs of our neural network. Which output is bigger? That means that our neural network is confident in this answer. So if answer apple is bigger, that means that our neural network considers that this image is apple. If mouse answer will be bigger, that it means that mouse is bigger. You don't see it in, for example, GPT neural network or another examples, but in such practical uses, you see only the final answer. But it is not difficult to programmers to understand how can you use 3 values to get one answer. And let's talk about data that we use to make our neural network model. Our data called data set. We have some terms from mathematics, from math, and in math we have general population term. That means that we have a lot of examples, for example, of humans. Every human in different times of several periods in our century, another century. So a lot of people, that is, for example, general population of people. And we should make some subset. In math, we call it sample. In data science, we call it data set. We get it and we can use it to train our model. If we use only unsupervised model, we can use this data from scratch. But if we use neural network, if we use supervised learning, we should label each human, for example, man or woman, or children and adult. So we should give to this data some another information. This is very popular task, especially 10 years ago. This data set called MNIST, and it consists of handwritten ciphers, 0, 1, 2, and images of these handwritten ciphers. Our neural network should look at this image and understand which class is it. So this black row, black column, is labeled data. For each image, we write which cipher is it. This is not image. This is only one class, 0, 1, 2, and so on. And so we have data, a lot of samples. Each image is one sample. For each sample in supervised learning, we have label. Label is mark, is answer of our neural network. It's answer of our expert that we make, but our neural network should repeat this answer. At this case, and when we train it, and after, when we use it in real world, it also should understand what is cipher, what is woman, what is man, what is adult, what is children. It should understand what we would like to get from our neural network. To do this, we should divide our data into two parts, train and test. Train is set of images that we will use in our training process. We use all these samples to teach our model, and our model try to learn everything about them. Then we will use test dataset that we don't use at training process, and we use it after, when we get trained model, and we should understand, is it good or is it bad? If we will give it another images from test dataset, and if our model answer good, it is good. If its answers are bad, that our model is bad, we should make something, we should repeat training process or make another model. And so this is dataset. It consists of many samples. Each sample has input, image, and label output. And all samples are divided into train, bigger, and test, smaller dataset. At our practice, we will use Cipher 100 dataset. This dataset consists of color images. In MNIST, you have only black images, black and white images. In Cipher 100, you have colorful images. It is a more complex task, and you have more classes. You have 100 classes. In MNIST, you have only 10 classes. MNIST is not a complex data set for nowadays models. Model nowadays can make prediction in handwritten ciphers very good, but such small pictures of different objects are very difficult to models. Not very difficult, but it is interesting task for today models. So it is very interesting to use this data set today at 2023. Each image has only 32 by 32 pixels. So 32 pixels height, 32 pixels width, and totally 124 pixels. This is 1 kilopixel, 1 kilopixel, very small image. Our phones makes megapixels, millions of pixels. This is only thousands of pixels. It has 3 colors. So we have 3 numbers for each pixels, and totally we have 100 pixels in 3 colors, 3000 numbers for each image. This is input for our model. It should use these numbers to understand what is airplane, what is automobile, what is bird, and so on. At this dataset, we have 50,000 images in train dataset and 10,000 images in test set. We have 100 classes. So for each class, we have 500 images in training set for each class and 100 image in test set for each class. This is about data that we will use in today practice. A lot of information, but I'm sure that it is very interesting, and I try to make my best to for you to understand what I talk about. And you can after that see some videos where you can repeat it and understand better. So we have data. We have some neural network about which we will talk later. But we should understand, is our neural network good or is it bad? How can we understand it? We should use some metrics. For example, we can make confusion metrics. What is confusion metrics? It has for numbers, for values, true positive, true negative, false positive, false negative. It can be challenging for you now, but it is not challenging if you will understand some basic rules. How can we understand what is true positive, what is true negative? If we have such task, prediction of cats, this is task of prediction cats. And if we have cat, we will answer plus. If we don't have cat, we will answer minus. So you can see here, this is right answers, and this is bad answers, because we have cat, we should answer plus. We have not cat, we should answer minus. Here is good example. We have bird, this is not cat, and this is maybe cat, maybe not. Let's talk, we'll think that this is plus, this is cat. So this is prediction of our model. This is answers of our neural network. Prediction is our answer of neural network. If it is right, so this cat, answer is cat. This is right answer. We call it true. If answer is not right, we call it false. And if answer was plus, it is positive. If answer is minus, it is negative. In this picture, we have minus, it is negative, and this is not cat, answer not cat, this is true. So it is true negative. This is true positive. It is maybe challenging now, but it's not very challenging. So we have a lot of images. We give these images to our model make prediction, and then we can compare, is it right answer or not? And we will calc this for numbers. How can we use these numbers then? We can make 3 metrics. The most important is accuracy, this value. We have 2 accuracies. This is results from our practice. So what we can see here, we have accuracy at train dataset, and we have accuracy at test rate dataset. Accuracy means percentage of the true answers. So we should calculate all true answers and divide it into all answers. This is percentage of our good answers, our true answers. And here we can see that our model at train dataset, at train pictures, almost at every image make good prediction. Almost all answers are true. But at test dataset, images that our neural network didn't see while training, it get it after training. Accuracy is lower. Accuracy is 77%, and this is 3 of 4. So every fourth answers is false. This is not very good. We would like to get something higher than 90%. And this is the main matrix, the main answer that you, when you train some model, this is the most simple metrics that you can talk to other people if your model is good or if your model is bad. If this value is close to 90% or 100%, it is very good. If it is low, your model is low, your model is bad. Even the accuracy at trained data set is very good. If your accuracy at trained data set is very high and test data set is not high, that means that your model is overfitted. It learned every data. It can repeat every answer, but it cannot reproduce dependency of real world. It just learn every picture, but it don't understand what is cat, what is dog. That means overfitted. If accuracy at trained dataset and test dataset are closer to each other, that means that our model learn real world dependencies. It can understand what is what. Also, here we see numbers of images in each class. So here we have 3 classes. This is apple, this is truck, this is otter. Oh, this is otter, this is truck. I learned every class in, not every class, but many class in Cypher Store. So this is numbers of samples in each class, and this is numbers of samples in test data set in each class. Totally 300 because we have 3 classes. Total data set have 100 classes, but you in your practice will use 3. You can change. You can use 4 classes, 5 classes. That is for your choice. But basic our practice is 3 classes. All other metrics I will not explain today because it needs more time. We have a lot of different terms today, and the basic is accuracy. So if test accuracy is high, that our model is high. Let's talk about what is neural network. So neural network consists of neurons. We have neurons in our brain, in our body, but biological cells are very complex, and in our artificial intelligence, we use only some mathematic equations. I will show how they look like. So it's not very difficult. So we have some image, and each image has a label. Right answer. We put image into our network. Our network makes several calculations, layer by layer. So this square is layer, 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 and this is also 4 layers. These points and these circles are neurons, and we make some calculation and get output. Here we have 2 outputs. Here we also have 2 outputs, cat or dog. If answer is cat and image is cat, this is right answer. If answer is dog but image is dog, this is false answer. Our neural networks consist of several layers, and today we will talk about the most simple neural network. It is fully connected neural network. Fully connected neural network consists of neurons, and each neuron has connection to each neuron of the previous layer. So we have this orange neuron. It has 3 connections because it has 3 previous neurons. This neuron has 4 connections because it have 4 previous neurons. We make connections only between nearest neurons, nearest layers. We don't make connection at this neural network between far layers. Here we have 2 neurons. Each neuron has 3 connections. Total 6 connections in 1 layer. 12 connection in this and 12 connection at this layer. These neurons are output layer, are output neurons. We get answer of our neural network. What is cat or what is dog? If this value is bigger, that this is cat. If this value is bigger, this is dog. These values are input, for example, our image, our 3000 pixels, and this is complexity of our model, hidden layers. We can make a lot of layers. We can make a small amount of layers. We can make small amount of neurons. This is for our choice. We should understand which how complex our model should be. In our example, we will use only 10 hidden neurons. Which mathematic we use in our neural network? We have some sum of the values. So we have some input, for example, some image, and we have weights. We should multiplicate input on weight and then get some summary. Then we can also plus some threshold and also make some activation function, for example, like this. Why we need this activation function? We need it to make several layers, because if we will not use this activation function, we will get only sum after sum, sum after sum, and this is similarly mathematic equation of one layer. So if we will not use activation function, that we don't need to make a lot of layers. This is we just need only one layer, only one output layer. If we will need a lot of layers, we should use activation function. Activation function like this, it was popular in past decade. What does it mean? If we have so this is value of our sum. No, this is value of our sum, and this is value of the activation function. If our sum is plus, that we will get something close to 1. If our sum is negative, we will get close to 0 value. So it's like light is on or light is off. Very simple answer. We should answer, is it cat or is it dog? So activation function can make this transformation from some sum into simple answer, 0 or 1, yes or no. Let's look like all these transformations look like. We have simple neural network, 3 input neurons, 3 hidden neurons, and 2 output neurons. And we have here 9 connections and 6 connections here. If we will train our model, we will get these weights. So each connection has weight, has some value. And here we have weights for this neuron. For example, this weight is 1. This weight is minus 2, and this weight is plus 2. So for every neuron, we can get these values. And also for these connections, we also have these values. These values we will use into in our calculations. These values we will get after training. If we know these weights and these weights are good, that means that our model is good, and we can use our model in inference. So inference is when we use, for example, if we ask ChatGPT, it is inference. When other people train ChatGPT, this is training process. So after training, data scientists get weights of ChatGPT, of GPT model, and you save them in these weights. Then you can use it in our calculations. So for example, you have some image, some text, it can be written in these numbers. For example, pixels. This is values of pixels. Then you have these weights, and you can calculate each this neuron using this simple calculation. multiplication and sum, and you will get this value for each neuron. After activation function, you will get one value close to 0 or one value close to 1, or some value is between these values. So this is like lights is off or lights is on. In here example, we will look at this answer. So this answer is bigger, but we need to use all of these values because this is hidden layer. This is not output layer. The same calculation we will make for this output layer. We have these values from the previous calculations, and we make a very similar calculation. So we will get these values: 0.35, 0.85. This value is bigger, so that means that our neural networks answer this second answer. For example, dog. It has some image and answers that this image is dogs. Well, this is simple example of neural network. Let's look at training process. How can we train our model? So we look at neural network, we look at data set, and we need also talk about this loss function and gradient. How can we understand what is good neural network and what is bad neural network, and how can we change it? So if you have some image, you have some answer for this image, and if this image is if this answer is bad, this is not right answer. We should change our model. This is example of this loop, of training loop. We have neural network, we put image into neural network, we get some output, and using right answer, right label. This is a label of our expert, and this is answer of our neural network. This is very good answer. It is very close. If it will answer another class, this is a bad answer. It is another class. It is mistake of our model. If this is mistake, we should train our model, make this process. If our model is very good, it can be stopped, training can be stopped, and we can use our model for inference. Let's look what is loss function, what is gradient. What is loss function? A loss function is difference between our model and labels of our data set. So for example, we have some prediction of weight, height, or using its weight, and our data about human weight and human weight. We can make a very simple model, a linear model, and we can see that different humans have different dependency of weight and height. But if man is higher, it is larger and have more weight. We have some difference between our answers and real data. If we will minus one data from another, so simply get one answer minus right answer and make square to make absolute value, and then sum them, we will get total error, total loss. If its value is big, this is square, so it is every positive, always positive. It is, if it is high, that error is high, if mistake is high. If it is 0, this is the best model that we can make, and we should make minimum of this function. Training process is minimum of loss function. Loss function in your knowledge should be associated with error or mistake. Loss function is mistake. Mistake should be minimal. How can we make it? We have some data for example, pixels, we put them into our model, and our model have some weights or parameters. At the beginning, it can be very slow, very low, about zeros. Then we will get output of our model, and we have also desired output or labels. And we can compare desired output and output of our model. Using this cost function, loss function, mistake, we will get this error. If this error is big, it is bad. If it is error is low, it is good. And we should minimize this error. How can we make it? Using gradient descent method, iteration method, using one step by another step, we can go down on our loss function. So this is graphic of very simple loss function. X and Y are parameters, are weights of our model, and that is error of our model. Errors should be low. This process maybe looks complex, but just imagine that you are at the top of the mountain, and everywhere are clouds. So you should go down, but you don't know where is the most bottom place of the mountain. You just see area around you, and you go down, go down, go down. You go to the direction where is mountain low. This is the process very similar how we train our model. We don't know the most bottom place. This is the problem of training neural network model. We only see a place where is value is lower. So we can get some model that is not the best one. This is the problem of gradient descent, but it works good. It has some modifications, and only that method we use to train real model for image classification, for text prediction, and so on. How can we make it? Simply, we should calculate gradient. Gradient is derivative, and for each parameter, we get this value. Using mathematics, using libraries, we don't need to make all of this code. We use just libraries like PyTorch or TensorFlow. We get all of these values for each parameter, for each weight, and we just need to minus from our current value of our weight this value. This we'll call later learning rate. If it is higher, we will make bigger steps. If it is low, we will make lower steps. And gradient is very difficult to calculate at such a big model like GPT and so on. So we use backpropagation method to calculate all of the values using such backpropagation. So forward propagation is calculation of our answer, then we get error, and then we can understand error for each neuron. We can understand how big error for each neuron. I don't talk about this calculation because we don't have enough time. But if you want to understand, you should learn about this method. Also, very important terms are iterations and epochs. So we have a big data set. It consists of many samples. And process when we put all of the samples into neural network and get all of the outputs is epoch. This is one epoch. The process when we divide our training data set into some portions, into some parts that we call batch or mini batch, we will and at which batch we will make training process. So we change weights of our neural networks. This is iteration, one step of training process when we change weights of our model. For example, you have some student, some people, and you can show him thousands of pictures. and try to get answer for each picture. You can give him one picture and then get answer. After that, you can show him another picture. After that, you can show another picture. So picture by picture, picture by picture. Or you can give him 10 pictures, another 10 pictures, another 10 pictures. So this will be batch. And each step when you show pupil these pictures and get answer, and then explain what is good or what is bad, what is right or what is not right. That is learning process. And here we can see difference between when we show only one picture. So this linear is very stochastic. When we show all pictures, very right linear. And when we use some mini batch, some portion of 10 pictures or of 100 pictures, this is not stochastic, that is not straight, but it is the most fast, the most quick process of learning to train our model. That have a lot of steps. Here we have a few steps, but they are very hard to calculate. These steps are not hard, but not a lot of steps. This is learning rate. What is learning rate? This is length of our steps. If our learning rate is low, steps are small. If our learning rate is big, our steps are big. If we have right learning rate, but we don't know this moment, we don't see the bottom of the mountain. If we will know the bottom of the mountain, we can, for example, blink to this place, and this means the right learning rate for one step to make right model in one step. But we need to make a lot of steps. And if our learning rate will be very high, we will not get to the bottom, and our model will be very bad. Here is a playground and TensorFlow. You can repeat all of the information that you learned today and make your own neural network. You can use this input data, you can use this output data, you can use some ratio between training and test data, you can use batch size, you can use learning rate, epoch, activation function, a lot of data, a lot of hyperparameters you can change here. And also you can look at the answers of the model, how it looks like. So everything you can repeat here. Next, overfitting. Overfitting is very interesting, but I don't think that we have enough time to talk about it. So if our error, we can calculate error of our model, loss of our model, each step, each iteration. At a training process, it mostly getting down and will lower and lower. If we will train our model a lot of steps, and our model is very very complex, it will be overfitted. So it will remember all of the images, and it will not get right information about real world. But if our model is not very complex, it will not remember all of the pictures. It will get some good answer. We can find this moment if we compare loss function, if we will compare error of the test data and train data. If test data is higher, that is moment of the overfitted, and we should stop at this moment of time. And also a very interesting technology that I use almost everywhere is ONNX. ONNX is library to convert models between different libraries, for example, Keras, TensorFlow, PyTorch, Caffe, into another library. So you can use it like some translator between different technologies. And also you can use ONNX in different languages. You can train your model in Python and use it then in JavaScript, in C++, and so on. And today we will look how can we use it at training of the model. I think, about 5 minutes to show you how can you train your first model if you are not familiar with it. I just need a few time to run my example, run my practice. So I gives you QR code. You can use this QR code. Now, you can find our GitHub. So I think now I can demonstrate my screen. So this is the GitHub of our university, of my department. And this is deep learning course. You can find it at the start page. Everything, not this course. Excuse me. You should go to the reports and find AI bot game.js, because this repository we use for our examples. And here you can see English version and English version of notebook. This is English version of lecture, and this is English version of node. You should use this notebook, and you will get such example that we call IPine. IPine, this is format for Jupyter notebook. Here you have this button, open in Colab. You just need to press this button, and you will transfer into the Google Colab platform. Google company gives us sorry, something. Yes, I need to change this button. Sorry. Okay. Okay. I will make it after the selection. I will change, but now I would like to show you how you can use it. I will use file from my laptop, and I think I can gives you my file at chat, and yes, I send you in the chat in Zoom this file, so you can download this file and upload it into Colab. So what we have here, we need to sign using our Google account, and here we have some cells. Each cells contains text to explain what we should do. All these cells contains code. How to run our code? We can use this button, play, and at the first time we will get connection to our virtual machine from Google. And how now we get some memory, some space to run our code. And here we have 7 seconds to run this part of the code. To run all of the cells, we can use these buttons. Sorry that this is Russian. You can use this first button to run all. If you will run this button, every cells will be running. And after training our model. So this is training of our model. We get error of our model lower, lower, and lower here. But this error is not lower. I can explain it at the end if we will have enough time. So here we have accuracy, 100 accuracy for trained dataset, but 77 accuracy for the test dataset. It is not very good. How can we make it better? For example, we can find moment of overfitting. How can we find it? We should find the most, I will show you very cheating process. You should find the most minimal value. For example, this value is the most minimal. So we should stop at the 72 epoch. How can we change number of epochs? We can change it here. So we just change number of epochs here, and we can again run all of the cells from the beginning. You can make it at the not at the beginning, but we don't have time to explain at which cell you can begin. You can run all of the cells separately. And here you can see that we have not very good answer. We have only 72%, but train accuracy is 92%. If we will make, for example, more epochs, for example, 100 epochs, I think we will get better results. So teaching of neural network consists of a lot of steps, and not all of them are very similar to repeat, but here you can see that a little bit bigger. So our accuracy at trained dataset is lower, but at test dataset is bigger. What can we make also? We can, for example, make a smaller learning rate. So we can make smaller steps, but we need more steps. Let's run all of the code again, and what we will get. For example, we will get here more good results, I think. So here we have not 76%. So we should find some. We have a very good example of the basic example. So it is difficult to make it better, but if we make several iterations, we can get better results. Here I show you some simple practices how to make our model better, but we don't have enough time to explain everything. We just need to use some best practices that you should learn to make this accuracy higher. And using these cells, you can save our model in ONNX format, and you will get this model here. You will get this file, and you can download it. You can download it here. And if we make some example in our repository, in our GitHub, you have one application, such example that I have shown you at the beginning of lecture. So what we can do, we can use this MLP of fully connected model. Then we can use image of Apple, for example. Then we can add several classes. that we use in the training of our model. At the beginning, you have labels of these classes. And here you have information about what our model thinks about our image. It thinks this is auto. This is not a right answer. If we will move our image, answer of our image of our neural network is changing. So here we can see that our model is not very good, but its answer is closer to Apple. Very often it gives us right answers, but because we have a lot of brown, I think it thinks that this we have some auto here. So we don't. This is the end our model. Thank you for listening me today. If we have some time, I can answer your questions. Yes, yes.
Sir, yeah, well, it's very nice presentation and it is very clear and crisp informations which you are giving for this deep learning, machine learning, as well as based on this artificial intelligence. Sir have explained very clearly with the LiDAR segmentation, which is for the unsupervised learning, and he has chosen the two data sets. One is used for the population sample data set, and another one is Cipher 100 data set, which is also explained clearly with the confusion data matrix. And sir, I think that in the research, sir have used this, having taken that training and testing data and found the result of precision, recall, etc. And he have explained clearly with the inference and how to train the neural network, which is in the supervised learning, and how the Onyx is used, gradient descent, iterations, etc. And also he explained how we can get the that is github.com from the repository, how the lecture notes in English, which we can download and we can refer for the future reference. And it's really very nice to hear your concept, sir. Thank you, sir. Thank you very much.
Thank you. Thank you very much. Thank you all of you.
Yeah, fine, sir. Thank you, sir. Rajkumar, sir. Rajkumar, sir. Rajkumar, sir, are you able to hear me?
Ma'am, I am here. I will share 2 minutes.
Yeah. I would like to invite Dr. Rajkumar, Associate Professor and Head, is going to explain the intellectual concept in the deep learning and machine learning. Sir, it is handover. The session is handover to you.
So, do you have some questions? So, would you like to discuss something, or everything is clear?
Sir, we need that your slides as well as your mail ID for future reference as well as to contact you. Can you share it in the chat box? Or
To
mail
share
ID?
my email, yes, I can write my email at the chat. So this is my email at Baum Moscow State University.
Okay.
To everybody. Here you can see my my email address, and also I can give you my page, maybe. But you can Google my name, I think, and if okay, if you need my name and my page, you can use this page in Russian, but it has a lot of links. a lot of links. So you can use them to find my Orch ID or Web of Science or Scopus ID to find some articles or find some articles in the list.
Sure, sir. I can get your slides from that mail ID. Thank you, sir.
Thank you.
Thank you. Rajkumar, sir, shall we proceed? Rajkumar, sir. Rajkumar, sir, please unmute your mic, sir.
Ma'am, my voice is audible?
Yes, yes, sir, your voice is audible.
One minute. 1 minute. Good evening to all. Ma'am, my voice is audible now. May I continue?
Yes, sir, you can start your
Sure,
session,
ma'am.
sir.
Sure, ma'am. Sure. Yeah. Ma'am, thank you for a nice introduction about me. Okay, fine. So in the today workshop, I am going to talk about the machine learning overview. If time permit, I will go
Rajkumar,
for
sir.
some demo.
Rajkumar, sir.
Yes, ma'am.
Only
Yes,
one
ma'am,
thing I
yes.
want to mention here, all our
Yes, ma'am.
students, sir, everyone
Okay,
need the
okay.
basic concept of the machine learning because for their project and all. So you can go
Yeah, sure,
according
ma'am.
to
Sure.
that. Thank you.
Yes, ma'am. Sure, sure. Thank you. Yeah. In my today's session, I am going to cover what is machine learning. Under the machine learning, what are the different type of techniques are there, and how they have classified those techniques. Those things we are going to learn, and followed by that, and what are Ma'am, his voice is audible. Somebody muted me.
Sir, sometimes your voice getting struck over.
No, madam, here somebody. Okay, no problem. Yeah, fine. Okay, fine. So followed by that, I am going to cover what are the limitation in the machine learning, then how we can overcome that machine learning through the deep learning concept. That's the thing I have planned. And followed by that, if time permit, I will show some of the demo using the machine learning algorithm. Okay, fine. And in the previous session, I seen our speaker from international, he shown some demo. I will really appreciate that. Okay, he spent some time to prepare that also, and also that's surely fruitful for the all the students. Fine. Anyway, now I will give all the brief introduction about the machine learning. Then I will move on to the what is machine learning elaborately. Fine. So basically, why we need machine learning? That's the thing we have to know first of all. I hope everybody know that in our day-to-day life, comparatively to the 10 years back, Now we can generate the data more by ourselves. For example, you have the mobile phone with you, yes or no? So in the mobile phone, using the mobile phone, wherever you are going, that scene you are going to capture. Then after capturing that, you are storing on your phone, and also later purpose you are referring that. But from that image or from that data, you want to do some task that by human it's take more time. You want to automate that, we need some of the technique. So that's why we are going for the machine learning. So basically machine learning, why we are going for, nowadays in our real world, we have n number of data. So from that data, you want to do some task. So it's very difficult for us to do. So in order to automate that, we need the machine learning algorithm. That is the one. So that's why here I have mentioned increases in data generation. So the data are increases day to day. So we need to automate, we have to do some task on that data. So we need the machine learning, one thing. And okay, sir, we are getting many type of data, even though whether those data are automated, whether those data are supervised or unsupervised. That means whether that is formatted or unformatted. Many of the data are unformatted. So what we have to do, first we have to format it. From that we have to extract some data, or from the unformatted, you can directly apply some of the learning algorithm, you have to get the data. So when do you have uncovered pattern, or when do you have unformatted data? So then we can use the machine learning algorithm. Even you want to do some decision making problem, so that we can achieve using the machine learning algorithm. For example, decision making, you are in your home, you are having the washing machine, yes or no? So whether you have to put the timing and water, how much is recovered. So based on the timing, it will run and then give the decision. Okay, we have washed the cloth properly. Is it clear? For improving the decision making problem. How here improving the decision making problem? Long back we had the washing machine with the semi-automated one. Now we have the automated one. So what is the difference between this? In semi-automated one, we have to pour the dresses, we have to take out, and we have to fix the timing and how long to run. And after some second or some minutes, we have to take the dresses, and then once again we have to put for wash. But right now we don't want to do that. Basically what happened now, automated, fully automated. Just initially you have to fix timing, water automatically will take, no need to do bother about that. So that is called as a improving decision making problem. This is one of the example I am giving for you. In addition to that, to solve some complex problem, what is make complex problem? So we have some volume of data. For example, you have in the medical images nowadays many volume of data are there. We need many expertise to find out what type of diseases are affected by the patient. So we want to automate that. We need the machine learning algorithm. Why do you want to automate? Because the doctors cannot be present 24/7 or 31 days per month, or 30 days per month, or 346 1 year. They are also having the family, they are also having the personal commitment, yes or no? So in such a place, if they are unable to present, so we want to solve such a problem, so we need the machine learning. So basically we need the machine learning to identify
Sir, voice
some particular...
ரொம்ப கம்மியா கேக்குது. கொஞ்சம் நல்ல louder கொஞ்சம் sound வேணும் sir.
1 minute, ma'am.
Yeah.
Fine. So basically for these are the reason, or basically to do this type of task, we need the machine learning algorithm. Basically we need the machine learning algorithm. Fine. Okay. Now when what is machine learning? So that is the thing you have to know. There are many different kind of definitions are there. Some people are saying automating automation, the simplest way for your understanding. This is not a formal definition. This is not a formal definition of the machine learning algorithm. Fine. This one thing we can say machine learning is automating the automation. Best example, whatever I said, that washing machine are getting computer to program themselves. That means you are going to give them some command to the system has to do all your activity. So for that, you can take the example as a robotic. You can take it as an example as a robotic. Or writing software is the bottleneck. That means you are going to write some software to do some task. So for that also we can use the machine learning. Or when the data are you have more, or when your data are less, so that time also you want to work, we need the machine learning algorithm. Fine. So what is the basic difference between our traditional programming and the machine learning? So in the traditional programming, for your understanding, I will take the programming C. Okay, I will take the programming C programming. Is it clear? So this is your C programming. So that C programming will run on the computer. So what is the input we have to give to our C programming? We have to give the input for your task. What is your task? My task is to perform the A plus B. A plus B is my task. So what is the input we have to give? Here we have to give the inputs of our value A and B. So this A and B value will take from the human, and then the C program will run on your system. Then it will provide the output, the addition of this A plus B. So that is the thing we'll do by our traditional programming. What about our machine programming? In machine programming, we are not going to give our program and input. Here, what we have to give? We have to give the program. The program should contain the logic. So how to take these two input and perform the task and provide the output. So that is the thing the traditional program will do. But in machine learning, not like that. So what we are going to feed in our machine learning? We are going to feed the input as well as output. Input as well as output to our computer through our machine learning algorithm. Through the machine learning, basically we are going to give here data and requirements they have written. No, data means your input. You can take it, your input. Requirements, what is the output you want to get from that input? So these two we have to give us an input to your machine learning algorithm. The machine learning algorithm will run on your computer. By running on the computer, it will give the output as the logic. So I am going to give the two number. So 2 and 4. So my task is the addition of this. That means I want to get the output as 6. So these are the two things we have to give it to the machine learning. We are going to get the output as how I am going to get this value as 6 output. So basically we have to use the operation plus. The plus is the operation we are going to get as a output from our machine learning program, machine learning technique. Is it clear? So basically machine learning from the given data will learn by itself and then give the logic. So what it learned. So that logic is given by the machine learning algorithm. But in our traditional one, we are not doing that. In the traditional one, we are going to give our input 2, 4, as well as the logic I want to do plus. You are going to get the output as 6. So this is the thing we are going to do in our traditional programming. In machine learning is opposite. Opposite means we have to feed input as well as we have to give the output. Logic we are going to get as a output. Logic we are going to get as a output. So that is called as a machine learning. Fine. Okay. Fine. Now we go for the simple definition of the machine learning. The simple definition is machine learning is the subfield of our computer as under the type of AI model. What is AI? AI is artificial intelligence model. Artificial intelligence model. So under the AI, we have one tree that is called as a machine learning. What I am trying to say, we have AI. So under the AI, one branch is called as a machine learning. Or you can take AI as a tree. AI as a tree. In the tree, one branch we have ML. The another branch we have deep learning. Is it clear? Within the ML branch, we have many algorithms. That we can take it as small branches. Similarly, in the DL we have. So that's the thing is happening. So basically in the tree is the AI, the seed. From that now many branches are booming. In that right now in our world is working, and also everybody doing their task with the technique that is called as a machine learning and deep learning. Fine. So how these machine learning and deep learning sir came? These machine learning and deep learning sir came from the topic or concept from the pattern recognition or computational learning theory. So what is my computational learning theory? The computation, the mathematical. So from the mathematics only, our machine learning and AI models are came. Is it clear? And what is the formal definition of the machine learning? The formal definition is given by the Tom Mitchell. So it's there in the textbook Machine Learning by Tom Mitchell. Okay, this is the prescribed textbook many people are following to learn about the machine learning. What it will do? It's doing improving the performance via experience. So that is the meaning of the machine learning. Improving performance via experience. So that means, one example, I said washing machine. No, earlier we had the semi-automated. Now we have the automated. So what is by semi-automated? So there we have some problem. We have to fix. We have to pour the water. We have to give the water, this much water to wash your clothes. So that is the sum of the work we have to do. There, what we have to do improvement. So we want to automate. Why the people has to stand in front of the machine? Just we have to do automate. The water has to be taken by the machine automatically. So that is called as a improving performance via experience. Here, what is the experience? Whatever you did in the semi-automated. So that is called as a experience. From that, we are going to do the automated. So that is called as a improving performance. Further, the formally he has given the definition. A computer system is said to learn from experience E with respect to do some class of task, and performance P will measure that. So that is the thing he has given. If you are not understanding this, I will give with one example. My task is I want to play in the chess. My task is I want to play the chess. So that is my task. Is it clear? That is my task. So if you want to play the chess, and what is your expectation from that? So I want to win the match. I want to win the match. That is the output you want to get. So how do you know you will succeed this many percentage? So for that, what we have to do? We have to do the training. What is the training? We have to keep on practice. We have to keep on practice. Okay, then only you can improve your performance of the percentage of the winning of the game. So that is called as a machine learning. Here the machine learning is playing. So your action, whatever you are doing for playing your chess, what is the action? You are practicing. That is the thing. Is it clear? Then the another example, my task is I want to driving the car in the public without the human. So that is mean we using vision sensor. So we don't want the driver. We want to keep the automated car, okay, with the vision camera or vision sensor. It has to work automated way. So here, what is your task? We want to make the car to drive or car to run on the public road without any accident. That is the main your task. That is your main task. So for that, what is your experience? What we have to do? We have to give the commands, and we have to give the sequence of images, whatever the vision camera is sensing in front of that. Is it clear? So that we have to give, plus we have to give the order. We have to give the command. So what after seeing that scene, what is that vision camera or vision sensor has to do? So whether it has to turn left or right, it has to go straight, or it has to ring the horn. So these are not some of the example for your understanding, for your example for your understanding. Okay, so fine. So what format you can give the data? What format we can give the data to the machine learning algorithm? So one is we can give the data. Okay, we have to give the data. From the data, the machine learning can learn. So that is one type of machine learning algorithm. One type of machine learning algorithm is the learning can happen on the machine learning from the data. So what we have to give, what we have to do, just we have to give the data. From the data, the learning algorithm by itself learn and then come for some conclusion. That is one way. What is the other way of giving the other way of we have to give the learning mechanism to the machine learning algorithm? Follow the instruction. Follow the instruction means we are going to give this some command. We have to give some command. So based on that command, your machine learning has to work. So that is the second format of the data we are going to feed. The next one is learning from experience. Learning from experience means, see, now I am teaching to you. Now I am teaching to you. Yes or no? So through my voice or through my content, you are going to learn about the machine learning something. You are going to learn about the machine learning. Here, this is called as this conversation is called as a learning from experience. Learning from the experience. The best example for learning from experience is teaching learning process. Teaching learning process is the best example for this. Okay, best example for this. Then when do you have to use the machine learning algorithm? Basically, we can use machine learning where the human expertise can't be present, where the human expertise can't present. So there we can use the machine learning technique. That is my point of view. Is it clear? Even in many textbook also they have given some scenario. These are the places we can use the machine learning algorithm. But my point of view, wherever you cannot go, there we can use machine learning technique. So that is the best one. And what are the application where you can use the machine learning technique? We can use the machine learning technique in n number of application. In n number of application we can use. Fine. But right now we are here I have given some of the few example for your understanding to classify the email message spam or not. So for that we can use the machine learning algorithm. We can use to predict the weather, whether today rain will come or not. So for the such a task we can use. Or the wonderful example nowadays, the peoples are buying the gold or investing money on the stock. You want to predict, so what happened after a year, after a month, if I put my money on this stock. Okay, so you want to predict that, we can use the machine learning algorithm. Okay, in addition to that, we can give some data. From the data you want to extract something. For example, I'm going to give this my scene data. So within that I want to extract only my face. So that we can do using the machine learning algorithm. Even we can do with the traditional algorithm, but their accuracies are less. What is by traditional algorithm? Using some mathematical formula. Using some mathematical formula we can do, but their accuracy is very less. You want to improve that. Accuracy means the identifying the human face. Okay, this face is Rajkumar. Rather than identifying Rajkumar, it's saying Ram Kumar. Then it's wrong, no? So you want to identify that. For that, we are going to use the machine learning algorithm. And also speech recognition. I am using my tone now. The same tone will be used by someone also. But I want to identify with the tone, whether this tone is given is belongs to this guy or not. So for that we can use the machine learning algorithm, or we can do computer vision task. Computer vision task. See, just now I gave my face is the one example. The face recognition, we can use the machine learning algorithm, or we can use for some recommendation system. What is the recommendation system? See, if you go to the Google, or if you go to this some Amazon website or Flipkart website, if you are going to search something, okay, then when you are go for after a hour or after a day, so whatever you search, that recommendation will be there on the system. Whatever you searched, okay, that will be there on your system. So that's why when you are going to log in on your account, then based on your previous view, the system automatically will give the recommendation to you. Why can't you buy this? Okay, these are the offers are coming. Is it clear? So these are some of the example for machine learning algorithm. Okay, nowadays in our system or in our world, every year around 10,000 or around hundreds of new machine learning algorithms are coming. Around hundreds of new machine learning algorithms are developing by the many people. Around hundreds of the machine learning algorithms are developed by the many of the person. Fine. And right now we can have around 10,000 of machine learning algorithms are exist on the world. But all the 10,000 algorithms cannot be adopted for all the data. It can be work for only specific type of data. So that's why the peoples are every day bringing some new algorithm. Every day they are bringing some new algorithm. Is it clear? So that's why we have to develop our own algorithm for our data. We have to develop our own algorithm for our data. Is it clear? See, even we can have 1,000 or 10,000 or more than algorithm, but those algorithm, it can't be generic. Can't be generic means we can't use that algorithm to do all the tasks. For example, in the previous session, the sir is shown the cat or dog, the separation. Is it clear? For example, I have developed algorithm for cat separation. Is it clear? I have developed the algorithm for cat separation. Okay, that's for only for black cat. Okay, rather than using the black cat, now I am going to use the different colored cat, colors of cat images. On that images, I am going to use the same, the black cat captured machine learning algorithm that learn accuracy of that black cat is 100, but the same algorithm I am going to use for the different colors of the cat images. So there, that machine learning algorithm cannot work. Is it clear? Because the colors are different, not only color, the internal properties are different. So that's why to adopt for your data, we have to develop the some machine learning algorithm. We have to develop the some machine learning algorithm. Is it clear? So that's why the peoples are developing every day some new algorithm for that. But right now, by combining all the data, we have one machine learning algorithm that is called as a chat GPT. That is called as a chat GPT. So the in the chat GPT, we have learned all the lakhs or millions of data we have learned that machine learning, that chat GPT is the one machine learning or AI algorithm that's did learning lot. Okay, the past years. Now, so from that learning, even you can give anything, you can get as a output. Anything you can get as an output. Is it clear? So chat GPT is the one of the example. Is it clear how that's power? Then the whatever we have developed the algorithm. We have developed algorithm for only for our machine, our system to work. But the chat GPT they have made for generic one. The generic one they have made. Is it clear? Okay, fine. So with this introduction, I will go for the machine learning algorithm. What are the components are there? Okay, in the machine learning algorithm, first component is representation. Second component is evaluation. Third one is optimization. Sir, what is my representation? The how you are going to show or showcase how you are going to implement the learning algorithm. That is called as a representation. Second one, evaluation. Sir, I have downloaded one machine learning algorithm. I want to know how much accuracy or what is the percentage of that prediction of that algorithm. So for that, we need the evaluation technique. So based on the evaluation, we are going to optimize our machine learning algorithm. So these are the three steps are playing, or these are the three components are playing inside the machine learning algorithm. So first one is algorithm. Second one is we have to evaluate the algorithm based on the output using the evaluation metrics. We are going to optimize our algorithm. After optimization, we are going to once again we are going to test with the same data set. So through this only the machine learning algorithm, the day-to-day life, we are going to improving it. Okay, fine. Now come for what are the different type of representation. Representation means different way, different algorithm or different techniques of the machine learning algorithm. Very old. Everybody know that decision tree is also one of the machine learning algorithm. What is this decision tree will do? It will do the logic. It will do the if then else rule logic we have to do. If then else rule we have to write for our data. So using the decision tree, we are going to write some rule. That rule we are going to show in the form of tree. We are going to show in the form of tree like this. Is it clear? So basically, it's like a if then else rule. You may return your C++ code, no? So like that, for the given data, the decision tree will form the rule. Is it clear? So that is called as one of the basic machine learning algorithm. So we have defined some rule. if you define the rule, then what happen when you are going to give the new data to that rule? Is it clear? So it's easily, it will take that data and will derive the conclusion. That is called as a decision tree. So what is the decision tree will do? From the given data, it will try to form some rule, and when I am going to give new data, this rule will take that data and bring the conclusion whether that given data is belongs to this class or that class, or it can predict, okay, this is tree and this is not tree, okay, like that. Okay, that is the thing we have to do in the decision tree and decision tree. In set of rules and logic programming, here just we are going to define the rule. Is it clear? Here we are going to define the rule in the that structure in the form of tree, but here just we are going to define the rule for the logic programming. Just you have to derive the logic. A plus B is the, I want to do the addition of two number. What is the logic? That plus is the logic. So that is the thing. Is it clear? The next one, graphical model is there. The next one is called as a neural network model. So basically we have started the machine learning with the rule based one. With the rule based one we have done, but later the whatever we have derived the rule, that rule is can't predict that prediction is not is equivalent with the human being. So that's why what is the people's are that why can't you mimic the human brain into the computer machine? So for that purpose only this neural network model is came. Is it clear? Neural network model is came. So basically neural network model is came to mimic our human being, because our human can predict more, or human can analyze more thing than our system. Yes or no? So initially the systems are done with the mathematical model, but later we want to do that mathematical along with our human brain model. So that is the purpose the neural network is came. So the neural network is the artificial neuron of our brain. Artificial neuron of our brain is called as a neural network. Very, very old neural network is called as a perceptron, followed by we have the backpropagation. This and all in the previous lecture is taken by that sir. Okay, that's why just I am skipping that. So just I am saying how that neural network is came. Then followed by the neural network. Okay, now the peoples are doing deep learning. The deep learning is the deepest neural network. Deepest neural network is called as a deep learning. Okay, and followed by deep learning, now the peoples are doing the transfer learning, and many things are there doing the transfer learning or ensemble learning, stacked learning. This and all is part of the deep neural network architecture only. Is it clear? So basically the mathematical model can't give the good result. So what the peoples are did, they want to get the good result by the system. So for that they have used the human brain as the mimicking machine for our computer. In that mimicking machine they have used some mathematical model. So that is called as a neural network. That is called as a neural network. Then that is called as a neural network. Then how you can evaluate our neural network model? So we can evaluate our neural network model or machine learning model using some metrics. What type of metrics we can use? So that metrics is called as a confusion matrix. You have seen in the previous lecture. Okay, using the confusion matrix measures, we can evaluate the performance of our learning algorithm. We can evaluate the performance of our learning algorithm. Under the confusion matrix, we have the measures are accuracy, F1 score, precision, recall, support, okay, and true positive rate and false positive rate. Like that we have many things. We can, whichever is adapt for you, you can use it for your learning algorithm. Then we can say we can predict the then we can predict the accuracy of your model. Then suppose your accuracy of your learning model is less. So we want to optimize that. For the optimization purpose only, we can use the gradient descent model. Even this also given by the SAR in the previous session. Fine. Next, we move on to how we can classify the machine learning model. we can classify the machine learning model. There are two ways. One is based on learning style. Another one is based on their function. Function means that logic. Based on the logic, how they are implemented on your data. So these are the two ways we can classify our machine learning algorithm. First, we will go for the learning one. In the learning, the first category is called as a supervised learning. Okay, supervised learning. So supervised learning here, for the supervised learning, I will take one example because you are going to do your research or your project in the next year, no? So or maybe in this year, in the next semester also you have to do. How you can use the machine learning model to do your research. For example, in your classroom, is it clear? We are taking your teachers are taking attendance. Okay, for example, your classroom, your class session is 50 minutes. Out of that 50 minutes, your teacher will spend only spending 10 minutes for taking the attendance. 10 minutes for taking the attendance. So that means only 40 minutes lecture is happen. Out of that 40 minutes, only 30 minutes the teacher will teach, and remaining 10 minutes, the teacher will ask the question to the student. So hardly only 30 minutes lecture is happen. Is it clear? As per your curriculum, you should have the lesson plan 45 hours. But out of 45 hours, you have only the 22.5 hours, because 1 hour lecture, they have taken only half an hour. The remaining half an hour is not happened properly. Due to that, so the teachers are unable to complete the syllabus. Is it clear? So many institute, what they will do, they will teach first 3 chapter, or they will teach only first 4 chapter. 5th chapter is seminar they will give, or you have to study by yourself. The reason is, this is the reason. So what we can do here? Why can't we automate this attendance system? Why can't we do automate? How we can do the automate? So we can do the automate using our face, using our face. So what we can do? So while you are enrolling on the institute, so first we will collect your biodata, plus we will collect your photo. Yes or no? We will collect your photo. So what I am trying to say here, when we can fix some camera in the classroom while students are entering, that is one point. Or we can fix the camera on the board. Is it clear? On the board, while the classes are happen, the camera will capture randomly some scene. Is it clear? Randomly some scene, and that images are given to the machine learning algorithm. Okay, we are going to give to the machine learning algorithm. Okay, what's the machine learning will do? Before you are going to feed your captured images, already while you are entering on the institute, we have captured some images. So those images, we have to train it on using our machine learning algorithm. What I have to train? Your face, and I have to give the label name. What is the label name? This is Rajkumar. Is it clear? This is Ajit. This is Ramkumar. This is Balamurgan. So like that labeling we have to give while you are going to give to the machine learning algorithm. So first what we have to do, we have to train our machine learning model with you are entered on the university enrollment number, and that time you are given photo and your name. So we are going to do some learning on the machine. What is the learning machine learning algorithm will do? So if this face is there, this is Rajkumar. So that is the learning will happen, and the label is Rajkumar is the label. And in your classroom attendance, we have captured some scene. That scene we are going to give to the machine learning algorithm. The machine learning algorithm has to do some pre-processing. Is it clear? Then pre-processing, it has to, in the classroom, maybe 30 or 40 students will be there. We have to crop each student photo, and that cropped photo we have to give to the machine learning algorithm. Just to photo only we are going to give. The cropping and all you have to do using your machine learning. Is it clear? The cropping, after cropping, we will take that cropped images and give it to the machine learning already trained model, and the trained model will match with the each face data, and then it will say this is Rajkumar. That is the one example for the supervised learning. You can do this type of one project we can do. This is one simple project. So like this, you can realize wherever you are doing some difficult task, why can't we do that automation? Why can't we do automation? This is one example. So this example is best example for under the supervised learning. Here in the under the supervised learning, here Tom and Cherry, there are two type of data I have given. Here Tom, you may take it as a my face, and the Cherry you may take it as a your face. Is it clear? And while I am training on the machine learning algorithm, along with my face, I have to give my name. Along with my face, I am going to give my name. So I am going to give this to my machine learning algorithm. Before going to the machine learning algorithm, if you need any data cleaning, you can do it. Any data cleaning, you can do it. What is meant data cleaning? So whatever the background information that is not required for the machine learning, we need only this area. So that we can extract first, then we can give that extracted face to the machine learning algorithm along with the label. The learning algorithm will learn by itself like human being. What is the human being brain will do? If I am writing like this, you can easily say this letter is A. How do you know this letter is A? Because from the childhood in the school, you learn this is A. And if I am writing this letter, so you learn this is A. Is it clear? See, you have learned and kept in your brain. So that's why when I am going to write like this, immediately you can say this is A. Same thing in the machine learning algorithm, we have to feed this letter is A. Similarly, I have to feed this face is Rajkumar. This face is Ajit Kumar. This face is Vijay. Like that, we have to feed. And when you are going for the testing, just you have to feed only the face. So the learning algorithm from the learned one already we learned in the machine learning in the brain. This is A. Similarly, when you are going to give the input, test input by the learning algorithm, it will bring the output. Okay, this face is Rajkumar. So that is the one type of project we can do here. Sir, can you extend this project to any other? Yes. For example, in the medical field, is it clear? If you are affected by some, if you have some fracture in your hand, so what the doctor will suggest to you, he can take the X-ray images, or you can take some CT images. Okay, after taking that CT images, what we have to do? Okay, by looking that photo, you can identify where is the crack is there. No, we cannot identify. What about your parents? They cannot identify. But who can identify that the crack is there on your bone? The expertise. Who is the expertise? Doctor is expertise. The radiologist is expertise. How they expertise? They have learned. They have studied that course. Is it clear? They have studied that course. So that's why when you are going to give that report to them, they will see that, oh, here the crack is there. So we have to give this type of treatment. They will identify. So here, if the doctor is not there, we are suffering. Yes or no? So why can't you develop the automated machine? After taking that X-ray images, we can give to the machine learning algorithm. Machine learning algorithm can identify whether in that images crack is there or not. So binary classification you can do. So that is also another type of problem we can do. This is another project you can do. The next project, what you can do, for example, rather than taking image, is it clear? Just you are going for concerning the doctor for fever. Is it clear? Concerning doctor for the fever. Is it clear? Or some regular diseases. Ma'am, may I continue? No.
Yes, sir. Yes, sir. Yes, sir. You can continue.
Somebody muted. Yes.
Yeah.
Fine. Okay, fine. Okay. The another project, see, rather than taking image, sir, why can't we work on the data? for that example, what I try to say, see, in the everyday, in the day-to-day life, we will have some common diseases. Common diseases are fever, cold, and stomach upset. Like that, some of the common problem everybody will face. Is it clear? So here, what we can do. So here, if the doctor, if you are suffered more, so you will go to the doctor. Such a time, if the doctor is not there, so what we can do? For example, so you are suffered by cold or suffered by fever. So that time the month is happen in your area. So you cannot meet the doctor. So what we can do that time? What we can do that time? So that time, so what we can do in our home, we can take the temperature by itself, by ourselves. Is it clear? And note down that temperature. Is it clear? So like that, what I am trying to say in the machine learning algorithm, the doctor, whoever met the patient, so the doctor has to prepare the report. Already the doctors are preparing the report. Okay, they have the report. They have the report in the form of Excel format. What they have in the Excel, they will write the name of the patient, age of the patient. Okay, and before happening that disease, where they went, that report they will write. Is it clear? So they will analyze the past 10 days whether the patient in the same city or traveled somewhere, or they went for some picnic, some cold places. That report they will write it. Okay, that also you can take it as a field, as a input. Followed by that, they will check the status of your body with the stethoscope, with that thermometer. So those information and all, they will write it in the Excel sheet. And based on that, the doctor will recommend some of the medicine. So you can take this medicine. Is it clear? You can take this medicine. So what I'm trying to say, rather than taking the image, so like this, whatever the disease the doctors are concerned, that report you can get it in online. You can get it in online. Some publicly available data sets are there. Some publicly available data sets are there to do this type of activity. So what you can do, you can take those data, you can take those data. Is it clear? And when you are going to give the new data, you are suffered by some fever. So we are going to analyze this data with already trained data, and based on that, already the doctor recommended some of the medicine. So we can bring that as an output. This is also another type of project you can do with the raw data, rather than images. You can do, these are the simple problem you can do using machine learning algorithm. Rather than go for the many students will go for a library management system, hotel management system. Don't do that under or developing the website. See, take some real problem like this and try to find such a data set on the online. It's publicly available. So, sir, in publicly available means where I can get the data. Go to the Google and type your project related topic and its data set. If you type, you will get surely from the Google website, you can get Kaggle, Kaggle. You can get the data set from there, or you can get the data set from the GitHub account, GitHub account you can get. Is it clear? Or you can get from publicly available, some of the institute or some of the research institute or some of the research center. They are hosted the image dataset on their website. You can download those dataset. You can work on that using machine learning algorithm. See, what, sir, whether I have to develop any new machine learning algorithm? No, I am not saying you to develop the new machine learning algorithm. Just I am saying to you, use the existing machine learning algorithm and try to work on your data set. Work on whatever you have collected the data set. There you can work. That is first you have to do. See, sir, already implemented machine learning algorithm. If I am using, whether they will accept our project? Yes. How? 1 minute. So how means, for example, one machine learning algorithm they have developed for the identifying of the cat faces on the data set. Cat faces data set. Is it clear? And another machine learning algorithm they have developed for identifying the laptop. Okay, that is the second algorithm they have developed. Third algorithm, they have developed for identifying the human, this face is human or not on the infrared images, See, if you see our data is present in many format, but a human eye can visualize only the visible sensor, whatever have the capacity, that amount only we can see. Beyond that, whatever is there, so that if you want to recognize or identify, we need the machine learning algorithm. Okay, we need the machine learning. Okay, come to this example. I said face, okay, and so on. The many things are I said. Many examples are I said. One is face, I said, cat, I said, another one is laptop, I said. So for these type of data set, they have developed one new algorithm they have developed. What you can do, whatever they have used for identifying the laptop on your data, so that algorithm they cannot be worked on the whatever your application is detecting the face. So for that data they cannot be worked. So what you can do, take that laptop identification machine learning algorithm and apply on the face data set. If you apply on the face data set, rather than getting the 100% accuracy, you can get only the 50% accuracy you may get. So what you can do here, in the 50% accuracy, you want to make it as a 100%, you have to modify some of the mathematical formula involved on that. Sir, what is the mathematical formula involved on that? I seen in the previous lecture that sir is given how the weight updation is happened in the neural network algorithm. Yes or no? Weight updation they have speak. Okay, in the weight updation, for the weight updation, we have to use some of the mathematical model. In that mathematical model, if you do some changes, sir, what type of changes I have to do? From the childhood, from the first standard, now till now, you have studied many mathematical formula. So try to use some of them to modify that machine learning model, machine learning logic, and make it that 50% accuracy, say 100 or 90 or 85. That is the one innovation. Okay, that is one innovation you can do. Sir, I am not an expert on that to modify that code. Rather than that, just to compare the different data set, for the different data set or different application, different algorithms are they have developed. Just you can compare and give the conclusion that, okay, if I apply this model, I am getting this accuracy. The reason is, in this model, this type of mathematical equations are there, but in this model, these mathematical models are there. You have to derive the conclusion. So if I use this type of mathematical model, you will get this type of accuracy. If you use this model, you will get this type of accuracy. Just that conclusion, if you derive, whoever coming for doing the research in the next time, so they will, from your conclusion, they have some idea. So rather than go for this type of this type of machine learning model, I have to go this type of machine learning model, I can get better accuracy. So these are the way only you have to do the research. These are the way only you have to do research, and then you have to enhance your project skill. Okay, fine. Another, ma'am, can you give another 10 to 15 minutes for me? Okay, fine. So this is, okay, fine. Now come for the how we can classify the machine learning algorithm. In the machine learning algorithm, we can classify into two ways. One is learning, another one is logical one. Learning based one is supervised. While you are training the data, along with your data, you have to give the label. That is called as a supervised learning. What is by unsupervised learning? Unsupervised learning means just I am going to feed the data to my machine learning model. I'm not going to say this is Rajkumar, this is Bharat Kumar. I'm not going to say. What is the machine learning algorithm will do? From this data, by itself bring the conclusion, okay, this and all Rajkumar faces, this and all Bharat Kumar faces. So this type of things also the machine learning algorithm will do. So the machine learning algorithm we can classify, one is supervised learning algorithm, another one is unsupervised learning algorithm. The next one we can say as a semi-supervised algorithm. Semi-supervised learning algorithm means is a combination of both supervised and unsupervised algorithm. So like that we can classify. Is it clear? And the next one is called as a, now this booming, and also many people are working on this. This is called as a reinforcement learning. In the reinforcement learning, just we are going to feed the data only, or whatever we have, that's only we are going to give. So from the data, the reinforcement learning by itself will learn and get the and do the sum of the action. Based on the action, it will get the reward from the people. Based on the reward, we are going to improve our model. For this best example, island. Okay, suppose I have placed you in some of the island. Is it clear? So in that island, nobody there. So such a time, how you will your action, how your reaction will be there. How your reaction will be there. How your reaction will be there. So based on your reaction, we are going to bring some model that is called as a reinforcement learning. So based on the learning, we can classify our machine learning algorithm into there are four ways. One is supervised, unsupervised, semi-supervised, another one is reinforcement learning. Fine. Okay, what type of data you can feed, what type of data we can feed it to this model? Okay, we can feed the input to this model. Either continuous target variable or categorical target variable.
Rajkumar
Is
sir,
it clear? Yes, ma'am. Yes,
Rajkumar
ma'am.
sir, we can conclude
Yes.
with this summary of learning.
Yes,
sir.
ma'am. Yes, ma'am.
Thank
Yes,
you.
ma'am.
Thank you, sir.
Another 5 minutes. Sure, ma'am. Sure, ma'am. Sure. Okay. So we can feed the data, these type of data, you can feed to this. So based on the feeding data, the supervised learning algorithms are named as regression. If you are going to give the data in the form of continuous form, that algorithm, supervised learning algorithm is called as a regression. If you are going to give the categorical data, that number 1, 2, 3, is it clear? Those type of algorithms are called as a classification algorithm. Is it clear? Unsupervised learning, we can call it as a algorithms are clustering or association. Similarly, semi-supervised, we can have either classification algorithm or clustering algorithm. Similarly, for reinforcement, we can have classification and controlling algorithm. So this is the way we can classify our machine learning algorithm. Under this each learning, these are the different type of algorithms are there. Now we can classify these algorithm based on its mathematical functionality. One is, we can call it as a regression algorithm. Under regression algorithm, these are the algorithms are there. And instance-based learning, these are the algorithms are there. Regularization, under that, these many algorithms are there. Decision tree, under the decision tree, we have these many algorithms are there. And Bayesian algorithm, these algorithms are there. And clustering technique, under the clustering, these many algorithms are there. And neural network, these are the algorithms are there. And deep learning, these are the algorithms are there. And time dimensionality reduction, these are the algorithms are there. Okay, and ensemble learning, these are the things. So, and other algorithms are these are the things. So what I am trying to say, you can classify the machine learning algorithm either based on learning style wise or based on mathematical logic you have used on your machine learning algorithm. These are the two ways we can classify the algorithm. One more way also we can classify based on the type of problem. We can classify the machine learning algorithm. Okay, so these are the way we can classify the machine learning algorithm. Just in this session, I have given what are the different type of machine learning algorithms are there and how we can use those things for your projects. So that's the thing I have given. Okay, and if you want to further, you want to contact me, go to this website. You can get my detail. Okay, you can get my detail. All my contact details are there. You can refer it. You can contact me. Okay. Thank you for giving the opportunity for me, HOD Indra Rani ma'am, and further and MKU University. Thank you, ma'am. Yeah. If there any query, you can ask. I am ready to answer you now, or even later also. You can contact me in this website. My contact numbers are there.
Sir, please post your mail ID in chat box, sir.
Ma'am, in this website, everything is there. Okay, anyway, I will share.
Okay.
All my contact detail is there.
So thank you very much. It's a wonderful session which you have given the basic concepts about the machine learning and deep learning and the types of problems which we have seen in the machine learning also. You have explained clearly. Now we came to the end of the session. If there is any queries from the students, you can raise the hand.
Hello, am I audible?
Ah,
Ma'am?
yes, ma'am. Yes, ma'am. Yes, yes.
Good
Yes,
evening,
yes.
everyone. I'm
Yes, tell.
Ramalakshmi. First of all, I'd like to thank Raj Kumar sir and for the wonderful lectures on deep learning and its application. Basically, I'm from a Max background doing my master's in computer application. This is the very first lecture for me in machine learning and deep learning. In this very first webinar itself, I got some crisp and clear ideas about the concepts behind these topics. Also, Anton sir as well as Rajkumar sir gave many examples. So with those examples, it was very helpful for me to understand even more easier. And I'd also like to thank our HOD ma'am, Dr. Indrani ma'am, for organizing this wonderful session. So it will be very helpful for us to do our project in the upcoming semester. Thank you, ma'am, and thank you, everyone.
Thank you, Ramalakshmi. Is any other one is ready to give the feedback? Any suggestions you can give me for the future? Okay, it's now the timer. It's my privilege to thank our Honorable Vice Chancellor, Professor P. Kumar, Registrar in Charge, Professor M. Ramakrishnan sir, who gave me this opportunity to conduct this webinar. I thank our Director, Dr. Muthupandi, and Additional Controller, Dr. Salima, who supported me a lot. Finally, Mr. Basha, who was the intermediate between the Madurai Kamaraj University and Russian House for this successful webinar. I also thank the two resource persons, valuable resource persons, that is Kanav Anton from Moscow and Dr. S. Rajkumar sir from Vellore Institute of Technology, who have given the valuable information regarding the deep learning, machine learning, as well as the artificial intelligence. So, finally, I would like to thank my friend, Dr. Padma Priya, who was the professor and head from Alagappa University, who have accepted immediately for this conference, for this webinar, to give the special address. And the chief guest, Madam Valentina, is also a very given a very wonderful and informative messages regarding the collaboration of the India and Russia. Thank you very much for the students who have patiently heard all these concepts which is relevant for your future projects. Thank you very much. And now, finally, now we can wind up the session. If there is any queries, anything, you can post through your mail ID, and within 2 to 3 days, you will receive your certificates. Thank you. Thank you very much.
Thank you, ma'am.